How would you evaluate this integral? The integral from 0 to pi over 2 of sine cubed over sine cubed plus cosine cubed. Now we can mess around with trig identities or u sub or even the tangent half angle substitution, but we could also just use the king property of definite integrals and we'll be done before you know it. Now personally I'm not a fan of kings, but I'll make an exception here because this property of definite integrals is just so slick. So what does it say? It says that the integral from a to b of f of x is just equal to the integral from a to b of f of a plus b minus x. Now I'm not going to prove why this property works in this video, but perhaps I'll make a separate video on that in the future. But you can convince yourself that this property holds by thinking about it in terms of transformations or even using u substitution. But let's see this property in action, shall we? Applying the king property to our original integral, we get that the inputs now of all our sines and cosines are pi over 2 minus x instead of x. But sine of pi over 2 minus x is just cosine x according to the cofunction identities. And likewise, cosine of pi over 2 minus x is just sine x. So making those substitutions into our function, we get that integral, the integral from 0 to pi over 2 of cosine cubed over cosine cubed plus sine cubed. Now we're going to do a very common trick in integration. We're going to let I equal to the value of the original integral, but our original integral also equals to our new integral after we use the king property. And so let's set that new integral equal to I as well. Adding these two integrals together, we get 2i equals to the sum of those two integrals. But according to the linearity property of integration, we can combine those two integrals into a single integral. But notice now the function just simplifies to 1. And that integral we all know evaluates to pi over 2. So dividing everything by 2, we get that I, the value of our original integral, is pi over 4. I just think that is so slick. Now my astute viewer may have noticed that we could have replaced the powers of 3 in our original integral with any integer n, and we would still get a value of pi over 4 for our integral. I'll leave that for y'all to check, but I think that's also pretty neat. And one more thing before we go. This video was inspired by this random paper I found on the internet by a Phil Petrocelli. So thank you, whoever you are. You can probably Google it and see the rest of the paper for yourself. But in any case, I hope you're doing well. Make sure to hit that follow button for more math content. And as always, I'll catch y'all in the next one. Take care.